The next topic is what? The next topic is energy. So it is also very important thing to understand the energy. So energy is what? Energy is a physical quantity, and the definition, what would be the definition of the energy? Energy is the capacity of doing work. Ability to do work is known as what? Is known as energy. Means capacity or capability, ability to do work is known as energy. Capacity or ability of doing work is known as energy. So two types of energy: mechanical energy, that means kinetic, and potential energy we'll see in this chapter. So there are different forms of energy, but only mechanical energy means the potential plus kinetic. That means combination of the both potential and the kinetic energy is known as what? Is known as mechanical energy. So we'll see only here the mechanical energy means potential energy and kinetic energy. So the definition, what will be the definition of the energy? The definition of energy is what? Ability to do work. Capacity of doing work or ability to do work is known as energy. And also we know that energy cannot be created. It can be, that means, transformed in one form to another form, and it cannot be destroyed also. So one by one we'll discuss. There are many forms of energy. That means energy are divided in two forms. First one is the kinetic and the potential. Also there are different types of energy like thermal, mechanical energy, electrical energy, magnetic energy, chemical energy, elastic energy, nuclear energy, and gravitational energy. Okay, and sound energy and light energy also. So there are many forms of energy, but in this chapter we only discuss the two mechanical energy. The first one is the kinetic energy and second one is potential energy. We'll see both two types of energy, and also we know the different forms of energy. There are many forms of energy, and only we'll see kinetic and the potential energy. Okay, so we'll see mechanics are comes out with the two kinds of energy in that means first one is what? First one is kinetic energy, and second one is what? Second one is potential energy. So kinetic energy, that means we represent it Ke, and the potential energy we represent it Pe. So Ke, the formula is the expression. The formula is what? K is equal to, means K is equal to half mv square. Half mv square, and also it is measured in joule. Means energy, the SI unit of energy is also joule. SI unit of work is also joule. Okay. So potential energy, the formula potential energy is what? mgh, and SI unit is what? SI unit is joule. Okay, so kinetic energy half mv square, potential energy is mgh. This is the formula, and this is the expression also. Okay, so first we'll see the derivation of the kinetic energy, and then after that the derivation of the potential energy. Both two derivations are very important, so we'll see one by one. So first is what? Derivation of the formula for the kinetic energy. So in the kinetic energy, first what we have to consider, kinetic energy of a body moving with a certain velocity is equal to the work done on it to acquire that velocity. Hence kinetic energy of a moving body with a certain velocity is equal to the work done. Kinetic energy, here you have to understand, kinetic energy of a body moving with a certain velocity is equal to the work done on it to acquire that velocity. Hence kinetic energy is also equal to the work done. Means energy is directly proportional to the work done also. Energy is what? Energy is directly proportional to the work done. Maybe kinetic, maybe potential. So energy is directly proportional to work done. Okay, so we'll see, let a body of mass m moves with a rest to the velocity v. Means if a body, the mass of the body is what? The mass of the body is m, and it is initially it is at rest, and after applying the force on the body, it attains the velocity what? It attains the velocity v. Initially it was at rest, m mass velocity, initially it was at rest, but after applying force, its velocity becomes v. Work done by that body will be equal to the kinetic energy. That means we have to prove work done will be equal to the kinetic energy. So we all know that here we have to write mass of the body is m, mass of the body is m, initial velocity is, that means u is equal to 0, final velocity, that means v. So all these things we have to write. After that what we'll have to do, distance covered by it, also we have to take that distance covered by it is s. We know that work is, so first we'll write the formula of the work. We know that work is what? Force into displacement, force into displacement, or we can write mass into acceleration into displacement, F into s. We know that W is equal to what? W will be equals to, we write W will be equals to F into S. Okay, we also know that F is equal to MAS, yes or no? So it will be MAS, because F, Newton's second formula, F is equal, in the place of F we can write MA, yes or no, and S, so MAS. Then after that, in the place of that means S, what we can write, in the place of S we can write the third equation, we can use the third equation of motion, and from the third equation of motions we put the value of A, because V square minus U square is equals to what, 2AS. This is the third, Newton's third equation. So from the Newton's third equation, we'll find the value of A, okay, and we'll write W is equal to F, in the place of A we can write V square divided by 2S, and already here is S, and S will be cancelled. So FV square half, that is FV square by 2, it becomes what, it becomes, see here, it becomes M in the place of S, sorry, in the place of S, that means it W will be equals to M A S. So in the place of A it is V square by 2S, and S cancel here, S and S cancel, so half MV square. Easily we can get half MV square here. Check this, half MV square, easily we can get here. So this is half MV square. Half MV square is the expression of the kinetic energy. So, and also W is equal to half MV square, means work done is equals to the kinetic energy. So this is the expression, half MV square is the expression of the kinetic energy. Okay, then examples of the kinetic energy. Shooting a rubber band. Energy, kinetic energy, what? That means energy due to the motion of an object. Kinetic energy, what? Due to the motion of the energy possessed by a body by the virtue of its motion. Kinetic energy, the energy possessed by a body by virtue of its motion is known as what? Kinetic energy. Means virtue of motion. The energy due to the virtues of motion, due to the energy possessed by a body by its virtue of motion is known as what? Is known as the kinetic energy. Means energy due to the motion. Energy due to the motion is known as what? Kinetic energy. And energy due to the shape, position, and is known as what? Is known as potential energy. Energy possessed by an object by virtue of its position. Its position, shape, or configuration is known as what? Potential energy. So potential energy, what? Potential energy, that means due to the position, energy due to the position, shape, configuration of an object. Kinetic energy due to the motion, energy due to the motion of an object. So kinetic energy and potential energy. So examples of the kinetic energy is what? Shooting a rubber band. If we are shooting a rubber band, means it becomes in motion. So energy due to the motion is known as what? Kinetic energy. Water falling over the fall. If water is falling, okay, that means water is falling means water is in motion. Now falling water is in motion, so it has the kinetic energy. If anything, any object is in motion, so it has kinetic energy. So energy due to the motion is kinetic energy. If the yo-yo, that means yo-yo swing is in motion, so it has a kinetic energy. Releasing the arrow from the bow. If you release the arrow from the bow, then when you release, then your bow becomes in, your arrow becomes in what? Motion. So it would have what? It would have the kinetic energy. So these are the examples of the kinetic energy. Also there are many examples of kinetic energy. Moving bus or car has a what? Which type of energy? Moving bus, car, and train has which type of energy? Kinetic energy. Moving bullets have kinetic energy. Flowing water has kinetic energy. Moving ball has kinetic energy. Okay, flying aircraft, if the aircraft is flying, so it has which type of energy? It has the kinetic energy. Blowing winds has which type of energy? Blowing winds has kinetic energy.